Forward to the-
All right. Okay, good, good. So, thanks everyone for joining for today's session. We're gonna step into a couple of more interesting topics. I'll bring up the chat as well so that if anyone types, I can see. So feel free to type any comments. I'll get to it throughout the talk. I prefer chat over like voice, so drop anything in chat. Um, Today we're going to talk about AI translation. And what we're going to talk about is how do we get, how do we move the goalpost and how do we get to the next step in um, actually deploying and using these tools in practice as doctors. And in order to do that, one of my key goals is to get you to think in a more nuanced way about what AI is, what it can do for you, and what it means for just knowledge work as a whole, and what it means specifically for medicine. So, for people who haven't met me yet, this is who I am. So, I'm a medical doctor right now at Monash Health in Melbourne. I've done research in retinal AI, the Center for Eye Research Australia. I joined the Cow Lab around 2 years ago now, and self-taught CS with machine learning a bit more formally at a sabbatical at Stanford. And I've done a whole bunch of projects along the way, mostly in AI translation, as well as education and also education like service and an app. So I think the goal is really to get nuance in evaluating sentences like this. So if I give you a sentence that AI is better than doctors at medicine, or if I give you something that says AI is worse than doctors at medicine, I want you guys to tell me what is the problem in even saying this as a phrase? Are there are there issues in laying this out as even a comment? Can anyone tell me in chat? It's worse. No evidence. Okay, it's vague. Yeah, I like the I like that it's vague. Compares as individual entities when they went to work hand in hand. Okay, good. Yeah, so we'll go through the evidence that exists right now. It's sentimental. Okay, good. Yeah. So it's not evidence-based, it's mostly emotional in a way. There's no basis for comparison. Okay, interesting. So it's not a smart comparison. Okay. Doesn't have emotional intelligence, which is essential. Fair enough. But I think again, the evidence is there's a lot of evidence suggesting that it may interact with patients in a better way, more in a more empathic way, especially on text. AI is not to replace humans. Fair enough. All right, good, good, good. I'm glad we have a broad range of ideas. So let's start with what we're going to do today. So uh that's so this is what we're going to talk about. So we're going to talk about we're just going to recap what we did yesterday very briefly. We're going to talk about AI as almost a different types of animals and different types of AI. And we're going to talk about what makes AI superhuman and what makes then institutions and hospitals and our healthcare networks superhuman. So yesterday we climbed sort of a ladder of models. Our job is to sort of go back and just return ourselves to what each of those are. So if you guys remember the slide on the good old-fashioned AI, so these are the rules-based AI that's very transparent, it's auditable. It's essentially saying if then something. And the limitations of this type of AI is that it caps the model at what the human imagination really is, and also caps the model at what human knowledge is, meaning it doesn't add any knowledge. Then we have statistical tools like regression. So this is again still the most common clinically used tools, like even like the Well score or any sort of calculator that we use nowadays. the human is the one who chooses the inputs. We're the ones who defined and validated some calculator on a lot of data, and then the model will it will create the weights to identify some sort of risk score. Again, this is what a lot of this involves a lot of human input of architecturing the actual formula for a regression. It also caps the model at what human imagination is for what matters. And then we spoke a little bit about decision trees. So these are uh, sort of graphs or clinical decision support tools where the model splits at different intersections. Often, as decision trees become more robust, we can get models themselves to decide where to split based on a whole bunch of data, and then they can find structures that humans would not have found. So that means that you are adding to knowledge and you're expanding beyond what humans know. However, you're still giving it a clear table of named va variables, meaning you're still selecting the information going in, meaning there's still human say in it, right? A lot of useful clinical prediction still lies around here. It's maybe when the trees get a lot more complex, it's less interpretable, but it's still very much about the quality of the features you give it and prepare to it. Then came deep learning. So in deep learning, the features are learned straight from the raw input. So this time you're not actually picking most of the variables in a sense, although you're the ones who is cleaning up the input, pre-processing it, and giving it to it. So these are learned features. And this technology is very much seen in, for instance, the convolutional neural networks we talked about yesterday in imaging, in radiology, pathology, and dermatology. This is the ones where we came out of papers saying that it outperforms dermatologists at detection of disease. And we'll go through that paper in a second as well. Um, what matters for this is we need large label data sets. But you lose a lot of the interpretability. That being said, if you guys remember from yesterday, we said that if we work really hard and use a lot of resources, we can interpret these. We often call these black boxes, but there are interpretability tools that can tell us at which layer, what sort of features are we looking at, like edges, shapes, and um, ultimately, it was one of the key things that changed in the 2010s, in the 20th, like 21st century, with the improvement of GPUs that allowed for deep learning to really start working. And we've got attention and foundation models, which is the last sort of rung of what's come up with large language models. And these are models that are trained on a vast corpora of unlabeled data, which then can be fine-tuned and adapted to for specific use cases. For instance, I can use Claude. If I wanted to, I could turn it into a note-taking app. And that's very much a general purpose AI that can then narrow down on a specific task and perform really well in it. And broadly speaking, if we think about the axis along which these models lie, it's about human input to a more data-driven approach. Along the way, we improve model autonomy, we improve model performance, but humans need to work harder to sort of understand them. It's almost like understanding a different species of animal. We've grown this thing, and now we're trying to figure out how it thinks. If we grow it with the right data, with the right tools, then it performs really well. But we still don't really know exactly what it's doing unless we spend a lot of time and effort to use interpretability tools to dig inside it. And what this means is, with this large spectrum of what AI actually is, we need to be far more precise. And when we talk about AI, language is really important. So I'm not sure if you guys have come across this before, but there's a type of tumor in the thyroid where it took us an easy way to label it a carcinoma, but took a large extended effort of 24 pathologists across several countries in one of the pathology society working groups to rename it or almost to dename it from being a carcinoma because making calling it a carcinoma made people want to manage it and cut it out. But in reality, it was far more indolent and did not, cause disease that warranted management. So it took a lot of effort to rename it, to make it appear as something that is, more benign, even for healthcare professionals like ourselves to not react to it. So what this means is if I say something like AI to predict sepsis, we're invoking a whole host of things. What type of AI, in what population, in what context, for what purpose, and how does it fit inside the workflow? There's also a lot of questions around clinical informatics of where the data came from, how it's being integrated into the pipeline, and where it's being stored, et cetera, et cetera. So if I say something like sepsis AI fails, we can see headlines from 2017 when Epic, one of the EMR providers, rolled out a sepsis prediction model to everyone. It's a proprietary model, meaning there was no insight for doctors to what it is and how it works, what data was trained on. But it was only later on with external evaluation slowly rolling in, and in 2021, when a large-scale investigation into its effectiveness basically showed that it was pretty poor in that it missed a lot of cases of sepsis, its accuracy and sensitivity specificity was quite poor, and it was alerting on far more admissions than it was relevant. So let's dissect this case, right? So this is AI to predict sepsis. The clinical goal is earlier prediction for quicker time to antibiotics, because we think that is a productive clinical goal. And the sepsis here is defined by the documentation of and through billing and coding of sepsis being defined as a clinical entity. The model is a penalized logistic regression. The data that was used is notes, vitals, labs, procedures, and medications, including antibiotics. Keep in mind that this is still a proprietary model, meaning we don't know exactly how they trained it, which is still a frustrating thing for the field and for research, but this is our best guess as to what they're doing. And for deployment, it was a default interruptive pop-up that you can't really opt out of to the clinician, meaning they'll be working on something. And when the model flagged it and when it hit the threshold for the likelihood of sepsis, it would pop up, even if the person had already been diagnosed with sepsis. There we go. So if we look at these criteria, there's some things that sort of should jump at us at failure modes of this entire system. Logistic regression is a perfectly fine model. It's something that's been used in research for a very, very long time. But just in the context of what this model is and does, it's defining sepsis by billing and documentation, meaning sepsis is defined post hoc, from which after a diagnosis is sort of made. So what this means is any model you predict sepsis to be is based on data where sepsis is already detected by the clinician, meaning it's not really useful because you're just sort of redoing what the clinician did. So it's not necessarily going to detect sepsis earlier. The data included things like antibiotics, which means that the model was actually learning, hey, this person used antibiotics here, so they have sepsis, which is not the right thing to learn in a way, because that just reinforces the fact that it's only going to flag as sepsis after a clinician has diagnosed the sepsis and started antibiotics for the sepsis. The deployment, it was regardless of if they've already diagnosed the sepsis. And you can imagine how frustrating this can be for a clinician where you're doing your own work and you get this pop-up that you instantly want to clear and you're not really going to act on it. Ultimately the goal of the model, it actually predicts recognized sepsis or treated sepsis because of the fact that it's using antibiotics and it's using billing and documentation. So its actual accuracy levels are really quite poor. Now let's think about a different phrase like sepsis AI saves lives. Again, we need to be more nuanced here. There's a good paper in 2022 about the targeted real-time early warning system. In this case, this is a multi-site study for patient outcomes after the implementation of this machine learning model. And the clinical goal here was, again, early sepsis prediction for quicker time to antibiotics. This time, sepsis is defined by physiological parameters, not billing and documentation. Model is a hierarchical mixture of experts. It's a fancy way to say a more sophisticated logistic regression. It's not very, is nothing that will be cutting edge or something that we can't evaluate. In terms of data used, we have the same notes vitals labs, but this time meds excluding antibiotic orders, and deployment is a passive icon in the EMR. And it only really flags when it's pre-diagnosis. So this is very important if you think about it, because it means that in the workflow of a clinician, you're not getting something popping up at you. You are just doing your work, and then when you're doing your paper rounds, when you're going through all the patients through their labs and making sure you see all the results as they come in, you get an ambient button that pops up that goes that when it pops up, you click on it, it goes, here's the risk of sepsis here. And these are the sort of data points, and you sort of know what data points is pulling from. For the goal of the model, it's defined by physiological parameters, it's predicting physiological sepsis before antibiotics, excluding antibiotic orders, in a way that's palatable to the clinician. And that actually allows for early detection. And then in this case, the sensitivity is far higher. Antibiotics were given faster, and when the alert was clicked on less than 3 hours, there was a mortality benefit of 3.3 absolute or an 18% relative for cases of sepsis. So in this case, this is a clear, um, this clearly tells us that sepsis or AI is nuanced. The models aren't even that different. The success behind the project is everything around it, of what it was trained on, like the everything we've been talking about to do with clinical informatics, good multi-stakeholder analyses, scoping the problem well, and ensuring you have the right infrastructure at your hospital for the right data compute and the right team with clinical input to lead it. So keep in mind, we're only talking about rules and regression. Regression, really, in both of those sepsis like cases. There's a new Epic model that's come out for tree-based gradient boosting, which is just basically a better decision tree, which should perform better. But I hope this allows us to realize a bit more that this, phrase we started off as, that AI is better or worse than doctors and medicine. Again, it's a flawed premise that even defining, like saying AI is actually quite a useless word in today's world. It's like saying that dogs are better than cats. And it really depends what, right? Like what breed, what task, and what are they doing? So I I hope that sort of really pushes it home for why we need to step away from a field as talking about it in such a black and white way. So now we're going to talk about superhuman AI. So this is really the promise of what AI is, in the sense that it can augment our thinking, it can improve, it can allow us to see things that um, machines can see that humans can't see, and that will improve clinical outcomes. And we need to think about what makes a problem solvable by modern machine learning or AI. And there's a really good talk by Jason Wei, one of the technical leads at OpenAI back in the day, in 2025. This is the title of the YouTube video. And he's broadly talking about, again, in this case, modern AI. So we're talking about large language models, we're talking about reinforcement learning and the training process of these large language models. There's a set of criteria for what makes a problem solvable by AI. We need data, so it needs to be data abundant. It needs to be digital because we're training in a digital sort of environment, and it needs to be verifiable. Verifiable means there is a ground truth. There is an answer to the problem. If we think about solvability, a really good example is actually mathematics. So around mid 2025 was when all of the different AI companies declared that the AI could solve to win gold in the IMO, one of the most prestigious, difficult mathematical competitions. And it has only really progressed since, where just a few days ago, we've got OpenAI disproving a very impressive mathematical proof. So, what this means is mathematics, especially proofs, are ones that are very difficult to create but easy to verify because you can work backwards to go, is this right or is this wrong? That means that with reinforcement learning, those issues, even if it's extremely difficult for humans, meaning there's only a small number of humans who can even understand what this model did, it will outperform humans by a vast degree. Now, think about what that means for medicine. Hopefully, I hope you guys are as excited as me in that I would love for a world where there are models who can be the top 0.001% of doctors and provide that care or provide help us make those decisions for our patients. Because ultimately it's better for patients and that's what we should strive for. If you guys know about AlphaFold, so that's a protein folding problem that was aimed to be solved through AI. It was if it was one of the first AI projects that's won a Nobel Prize in chemistry. Again, the formula is very simple. It had data in the protein data bank. The sequencing were coordinates were that you could convert them into a digital environment, and it's checkable against known structures. So this means it's a problem that's amenable to being solved. Oops. However, there are a, just because some biological problems can be solved doesn't mean that all can be. So things like binding affinity are far more difficult to verify because there's no clear, abundant ground truth set. And it really means that society's efforts now is about trying to figure out these three things for most problems because it means that downstream it will be solved. Now, let me broadly just chuck on a graph what this means for verifiability of medical things. So we have imaging diagnoses, and this is likely things like pathology, radiology, and dermatology, which are have a clear ground truth. They have a picture and a disease, right? It's easily verifiable, but it's difficult for someone to create that diagnosis, meaning you normally need a human with a lot of training, decades of training to accurately come to the diagnosis. But since we can now generate things that are difficult but easy to verify, that becomes something that's very easy to solve. Things much harder are things like predicting treatment effect in a very complex environment of a human body in a multi-morbid patient, or just open-ended reasoning where there's no real right answer, but you're trying to weigh up a whole host of other factors, even things like geography, the patient being able to go home that day, or their wishes and desires to end up giving the right medical management for that patient at that time. This means you're really treating the person and not the pathology. Now, we need to, I'll just answer a couple of the questions. So I've got one that says, but won't that mean less human professionals? I think there are different ways to consider that. I think what that means is we have these cognitive things that can help us come to good clinical decisions. That doesn't mean that it will actually improve the efficiency, though, because it's a matter of how it integrates into our workflow that will cut down time. And only when you cut down time will it improve efficiency and actually allow us to have less professionals for the same number of patients we treat. It also means it's there's a common law in whenever anything becomes a commodity, like if intelligence is a commodity, that the demand for it actually increases, meaning in the improved efficiency of services, you end up more people accessing healthcare, more people getting better, which actually drives demand further. So that that's one way to look at it, that humans won't be needed as much, but there's a lot of good evidence that it just changes what the field looks like in both positive and negative ways for humans. Deployment access. I'm not sure which slide you're referring to. Um, I'll if you could turn that into a question, I'm happy to answer that. This one? Oh, this one. Oh yeah, yeah. No, I'm about to say that. Don't worry about it. Okay, so moving on. I just told you that verifiable problems are solvable. So these are problems that have a ground truth, they have a right answer. Now think about it. So if the way that we evaluate AI is through benchmarks, which are basically um, questions and answers, or an environment for it to do the right thing, because that's how we test things. Like we give people exams because we want to figure out if they're able to do certain things. If there's a right answer, that means that it's in a sense some degree of verifiability. There's a ground truth. So what this means is that there's almost a law that whenever there's a benchmark, it will be solved because it's something that can be put down to pen and paper to having a question and then having a right answer. So this is what we see in the past several years. Benchmarks have been saturating, meaning in just a few months, benchmarks that scored less than 10% in 2021 now score more than 80%. This is just a matter of having solving the three factors of an abundance of digital data that is verifiable. So, what does it mean for medical benchmarks then, right? So, this is there were many early attempts, so in the large deep learning era, to solve visual and image-based problems because those are the ones that, again, have a clear input, the image, and output, which is the diagnosis. It's digital, again, heavy volume data and very verifiable. Medicine and clinical reasoning is not too different. So when we have benchmarks like the MedQA, which is just the USMLE type MCQs, you end up with titles saying that, hey, AI can pass the medicine licensing exam. And very quickly, that's something that it can get 100% on now. And more complex agentic benchmarks that aims to help it integrate into the workflow of doctors is also undoubtedly going to get a lot better. The next sort of question for the field and a lot of what generated a lot of conversation and excitement was comparisons between LLMs and humans. So this was a 2024 paper which demonstrated that AI is there's no real difference or no real improvement for AI plus a physician than AI by itself. But physicians by themselves were broadly not going to perform at the same level as AI plus physician. Now, what am I really saying? I'm saying that an AI can perform well, human plus AI can perform well, but physicians without AI won't perform as well. A follow-on paper aim to evaluate a similar thing, more about management and factors of rather than just diagnosis that further reinforce this. And again, there was no significant difference between just GPT-4 itself and GPT-4 augmented physicians or physicians that were working with GPT-4. Now, there's a lot of takeaways and further directions for research in this from these results. Questions like, what does it mean for them to work together? Are they really working together well? And are there real better ways for humans and AI to collaborate? This is a part of it then grew out of a subset of a field called human computer interaction, which is essentially a field of how people study, they study how people interact with computers. And it's already been an area of research, even in 2020. In this case, they were trying to figure out the best way for a clinician to integrate AI into skin cancer recognition. And what they ended up doing was AI to have its own cognitive task, which is to provide probabilities for a multi-class classification, meaning for a whole bunch of diagnoses, it would give us a 0 to 1 probability of a diagnosis. And a clinician would then use that information alongside what they normally do, so their own read, the context around the patient, and then they'd come to the final diagnosis. You would hope that there is sufficient things here for us to warrant um, for us to offer more patient-centered care and for us to also outperform the AI. and we'll get to the outcome of that in a second. There's a preprint currently in process, which is an RCT for collaborative workflows with LLMs, which is essentially the same paper as the dermatology one, but more applied to clinical reasoning and using large language models. And it's doing something that's a little bit interesting. So now the scope of the AI is, again, much like the dermatology one, it very much overlaps with the cognitive scope of the clinician, meaning both of them are sort of doing the same thing. You have a AI that's independent and it's running the whole full diagnosis and assessment. You have a clinician who's doing the same thing. The AI would synthesize it and compare and contrast them for and present it to the clinician who can then verify and think more about how they would change their decision making. Here's a graph that broadly sort of underscores how it went. Uh, Essentially, human plus AI, the lowest bar is human alone. Human with AI, the humans perform substantially better, but it generally lands at or just around the AI alone bar. But we've not yet found a way for collaboration to work that makes humans better than AI. Now, what does this mean? There's a lot of further questions and thoughts to think about this. Also, keep in mind that this paper is still in preprint, so it's yet to be published, and it's likely the results are going to change. So, what this means is it has a lot of implications for collaboration, but it also really goes back to the three factors for solvability of a problem. If you think about it, just by virtue of it being a benchmark, it is at least somewhat verifiable. There's some correct answer. It's clearly there's enough data for the AI to make decent decisions, and it's obviously digital. So what this means is AI is almost a great chameleon or a mimicker of humans. And if it's ingested all of human knowledge, it's likely that and possible that it's the ceiling for verifiable work. So the question then is, what is the work that humans can do that AI can't do? And the unverifiable part is by definition the region you can't turn into a digital abundant benchmark, which means by definition AI can't be superhuman at it. And then we can think about what sort of problems resist measurement. Because if it can't be measured, it can't be data abundant. And often problems that resist measurement are not verifiable either and can't be put down to pen and paper and made digital. Is that things around the art of medicine? There's surely things around true novel presentations and broadly interacting with the human condition. And there are possibly even diseases that we're not characterizing properly with improper measurement, meaning the lack of measurement is just that we haven't measured the right thing. So, for instance, in CML, before we knew that it was driven by a BCR-ABL genetic mutation, we that disease had a whole host of other hypotheses for what it was, and its management options were very different. But once we identified the actual lever and axis for that disease, tyrosine kinase inhibitors basically solve that disease overnight. So I hope that leaves you with some things to think about for what makes AI powerful and building superhuman AI. Now let's think a little bit about making and building superhuman institutions. So medicine is a whole load of cognitive work, but also a lot of human work. The ceiling, if we consider the ceiling for measurable cognitive work to be what AI can do, then really there's a lot of value to the unmeasured residue and to local knowledge. And this is things to do with any sort of idiosyncratic or specific patient population, even counterfactuals of asking questions of if I did X rather than Y, then what would have happened? Those are things that are not, when you operate at multiple intersections of that sort of questioning, you end up with far less data to drive those sorts of questions. Then it relies on things like people like humans who are better general purpose thinkers at this point, who require less data than AI to reason through, and especially for rare and uh, difficult presentations with non-existent data. So this is sort of where an institution's sort of value will end up lying. It's going to be far less in the verifiable, measurable core, but likely more in its ability to serve its population in things that are not being measured, or it's very difficult to measure, or it's simply hard to measure. That being said, the residue of the unmeasurable will slowly continue to erode as more things become measurable. But it's the nature of humans, I believe, to notice more things and recognize more things, meaning there'll always be a residue, which is broadly saying that there's going to be more progress to be made in any field. So, from an institutional perspective, whatever you build on the measurable side is largely a depreciating asset, but whatever specific knowledge you gain on the in the residue is going to augment your institution far more. And very practically, what this means is it's likely that if you own a hospital or if you are involved in decision making at a hospital, you don't really have a strong need to build your own AI model and to train and or fine tune a large language model from scratch. It's likely we'll be using benchmarks and we'll be renting from vendors for what the best AI is at a specific benchmark for a specific population that aligns with the population your hospital is serving. The unmeasurable residue will be something that you will own. And where that comes from is your data substrate for what your specific population has, what their specific needs are. And this means that healthcare will become far more personalized. And alongside that, in the quest or task of measuring things, there'll be an explosion of measurement for what is, and people will aim to measure more things, which will largely, I believe, drive scientific progress and medical progress. Uh, Good. That's sort of where I wanted to leave us off at. I was hoping for any questions or answers or any thoughts for us to share, and that'll be it from me for today.
Thank you so much, Deepak. Please, uh, before we go on to ask questions, please let's give Dr. Deepak a round of applause for this wonderful session. This was a continuation of what he started yesterday. So yeah, let's keep it coming in. So I think someone asked for permission to ask the question on the question box. Okay. So you can raise your hand if you have a question, and you can also put in your question in the chat box. Thank you for thank you. Okay, there is a question.
What could
Dr.
those
Deepak, I
data
don't
be
know if you
kept?
can see the question. What could those data that you keep to yourself be?
Yeah, it's a good question. I think it will come down to data that is um, again, the reason I ended up at personalized healthcare is it's likely data that it will help few people, but not everyone. Meaning, larger companies will be less interested in it because it doesn't generalize as well. But hospitals will be very interested in it because it's something that will be specific to their patient population. This can mean things like specific ethnic groups and demographics that um, interact with certain things or have certain preferences or show that for whatever reason, healthcare is delivered differently to them. Um, for specifics on the data, though, I think it's very variable and dependent on the reasoning behind it. But for instance, it's likely that one ICU, if you take it in far more granularity, will have differences to another ICU just by virtue of what resources it has, which allows it to make different decisions on management just by virtue of the patient population it sees and the bodies that come through. And I think that means hospitals will have an incentive to basically build more measurement tools for their specific patients so that they can integrate that with larger sort of quote unquote like larger AI and cognitive task solvers. Can models be generated with low volume data for rare conditions? They can. So I think they can, with the caveat that ultimately you still try to solve the three things of the low volume data. I've seen examples of people using synthetic data and to some effect, to some decent effect. So the benchmark humanities last exam is all about questions that are incredibly difficult just by virtue of the almost by virtue of rarity of the answers. And it's all about questions across all sciences that are incredibly niche and only be answered by a small number of experts in the world. What that means is, uh, and AI has shown to improve on that benchmark over time. What that means to me is that the training process is indexing well on very niche information as well as general information. And that being said, I think those experts who own more data that's private will be in a better position to solve problems than AI can, just by virtue of them having the data.
So there's another question. What data will you advise to be used in Africa when you want to open a hospital?
It's an interesting question. Hmm. I think the most important things for any hospital in any part of the world to get correct is a data pipeline, meaning to have the right infrastructure in place to store your data in what is likely going to be a data warehouse or a lake, to label your data properly, have a good data dictionary, and have competent and train your own clinical informatics staff to access that data and to do interesting things with that data. When there's a local context of some country or continent, I think that will show up in the data itself based on the presenting complaints that come through and what management options are commonly used. I don't, I'm not too familiar with what specific needs there are around data in Africa, but I feel like the broader, highest leverage thing that can be done, which is still not really well done, even like even in the hospitals that I collaborate with, that I see very, very oftenly, is just not good data pipeline methods because it hasn't been in the interest of business intelligence and just, business as usual. Uh, Not yet, anyway. Although there's a lot of variability between different hospitals at this point. I can see the next question. How do you see this advancing healthcare in Africa? Because from little experience, incorporating gets complicated, it doesn't advance healthcare at all. So when it's kept simple, it works. How do you keep it simple? Yeah, I think that's a good question. In low, like even when I work on projects where the technological infrastructure doesn't support the current need, like the current tools that exist, I think that the we just have to peel back the layer to what is the thing that's missing or what is the blocker. So, for instance, uh, in hospitals where I see technology not being integrated properly, if we peel it back, it's actually a very disjointed system with a lot of different solutions solving different problems that don't integrate well together. And a lot of early decisions that were made that were quite poor. And there's also obviously the like a lot of hospitals I work with don't have a lot of money to use as well. So they're just sort of staying afloat and trying to get by. And there's not much funding to move things forward. I think in situations like that, the best thing that can happen is a long-term relationship with that hospital where you slowly solve small but important problems using technology. And the phrase that I've settled on is the path of you just try and find the path of least resistance, which is often the path of most support. So you need to find problems that everyone agrees is a problem. You need to find a solution that is amenable to your current infrastructure. And luckily, even AI nowadays is incredibly easy to integrate and relatively affordable, especially for local models or all of those open source models that I mentioned earlier yesterday. Once that is done, if there is often there's some business case that can be translated to. I encourage you all to learn some biodesign. So, but biodesign refers to the process of translating and solving healthcare problems. It's a very principled way to solving healthcare problems with technology. It was developed out of Stanford, etc. And it broadly allows us to align the population, the problem, the payer, and the outcome. And when we have all of those things aligned, then we create something that generates that's self-sustaining. It generates its own wealth, and it's also solving important problems. I hope that helps with that question.
Thank
Next
you
one
so much.
was yeah. Next one was AI works based on data is trained in. So if it's incomplete, yes, 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 definitely, yeah. Um, your that is 100% true. So there's a lot of still effort that needs to be done to make AI truly equitable and able to uh, reliably help us in a way that's not going to perpetuate the biases in the data. Again, I called it a chameleon, right? Or like a mimicker. It's not going to do things out of what humans do, meaning there are definitely problems humans don't solve well, especially around bias, and it's just going to continue that. So it's incredibly important whenever there's clinical application that we consider that, and I think that that's the power of the private data and making sure that models are fine-tuned or aligned to your local population. Even in this paper, like in this the one where oops, with LLMs and humans collaborating, they attempted a couple of different approaches to see if AI should go first or humans should go first. So in this one, so two orderings, AI first and AI second. So what happened was if AI went second and it can see the clinician assessment, it was far more sycophantic, meaning it was far more likely to agree with the human, and it's far less to have sort of think independently. And it would be biased based on what the clinician's seeing because it's sort of trained to play to human preferences and to please humans. So even in its behavior, even if you explicitly tell it not to, it had a large rate of failure in AI second. So that means certain things about we need to understand the behavior of these models before we integrate them anywhere, because there's a lot of subtle things like that which we won't expect, but we will see once we study them. But the overall answer is, I think if you have if you are well principled, if you have a lot of experience and good staff who can clean up your data properly, identify the biases in it, I think AI can make reasonable support for decision making and diagnosis making, uh, provided the data is good and robust. Quite interesting to see AI outperform humans, yet the best results come when AI and humans work together. Voice says a lot about the future. If we had to predict that, AI may take over many personal tasks partly because we're continuously training and improving systems ourselves. How do we say humans are essential in the loop? Um, so I think I'll push back on a little bit here. So I don't think so I think we need to realize that so in both of the examples that I gave y'all for the two examples of humans working with AI, what ended up happening is that the scope of the AI's task is very much the same as the scope of the human task because it's doing the same thing. And then we then go post hoc to combine them together and see how if AI agrees or clinician agrees, and then clinician gets the final say. Uh, it is broadly speaking, the research has not demonstrated that AI and humans outperform just AI. we know that AI and humans outperform just humans, meaning humans hit the same ceiling as the AI. Um, I think what that means is, from my perspective, it's likely that we're not scoping the problems well, meaning there should be tasks that humans can do that AI likely can't do. The difficulty is that it's likely they are unverifiable tasks or unmeasurable tasks, which point to, a lot of patient care comes from the things that are. There's a good quote from, I think, William Osler, which is one of the grandfathers of medicine or whatever, and one was, you treat sometimes, but you reassure always. I think things like that of the human side of medicine, because not all we as doctors know how imperfect medicine can be. There's not a lot of diseases that we can snap our fingers and fix. Um, and what that means is it's more than just clinical reasoning and or like pure like biochemical reasoning. And uh, I think it means that we need to let AI do what it does well, and provided it gives us the results, I think if it outperforms humans, we should let it do what it does, and we should do what we do better. But the tricky part is that there's a chance that since it's unmeasurable, it's difficult to make that case because you can't really point to what humans are doing sometimes. But I think it's a very open question of how we ensure humans remain essential in the loop. And some people's answers is maybe we don't need to, because if AI is at the same level as a human, we will what was the question? Was from the solvability, diagnostic accuracy by condition. Uh, are you talking about like diagnostic accuracy for conditions? Like just like the early benchmarks, or but I think broadly what I'm going to say is probably quite similar, which is that there are tasks like diagnoses that AI can outperform. So it's a matter of scoping it and letting it do what it's strong at. Oh, that one? Yeah. Yeah, so that graph largely demonstrates that AI alone there's no significant difference between human plus AI and AI alone. So again, the difficulty is that this is a very discrete task that's measured, that's verified. So you would sort of almost expect this because everything I've been telling you guys is that if it's data abundant, digital, and verifiable, AI will perform on the same level, or humans will perform on the same level with AI. Um, so I don't think we have a good answer to like how do we ensure humans that remain essential in the loop. We know that many medical conditions differ. Yes, yes. Acromegaly diagnosis when it's limited. Yes. It's a great question. Um, I think the data abundance is going to be a problem, especially when AI is built increasingly by um, countries where there's a disproportionate difference in data and availability of data. Uh, I think again, the only way it can produce those accurate diagnoses is if there is more data collected uh, to train them and just generally to have access to them. I think it's a very important problem. I think, however, it's also true that modern systems are better from learning from small amounts of data. So there's a large idea in ML called transfer learning, which aims to use sort of quote unquote like general purpose models and then fine tune on a smaller subpopulation. Um, the this was demonstrated even in the CNNs, the vision models for dermatology and stuff. So broadly, it was you create your first convolutional neural network, and then you have a much smaller data set, even around. Um, I think it really depends on the case, but numbers even can be around 100 or 150. and it shows significant improvement in accuracy in that population, provided it's been fine-tuned on that population. Meaning, I feel like it's uh, the required data for good representation is not as much as people expect, but it's definitely true that you need the right data to be collected, and it's definitely true that you need for that you need the right infrastructure and all the right things to be in place for the data to be collected. Summary of what the Car Lab does. So, the Car Lab is a group of doctors and engineers who essentially help with projects. So, we run a whole host of research and industry projects to further medical AI. Our broad goal is to make AI, AGI, and ASI accessible to everyone. And the way we're currently doing that is building awareness, education among as many people as we can, and doing as many cool projects as we can. Yes, personalized medicine. Hmm. Yeah, that's a really good question. So I think personalized medicine will arise less from the single shot like predictions and far more from the long form data is that is collected from people. So what I'm basically saying is if someone talks to ChatGPT about their life and their problem, suppose they have a disease and they're trying to figure out how to cope with it, it's um what we've found is that multi-turn conversations are and in multi-turn conversations, there's far more opportunity for the AI to learn more about the human. And in those processes, it ends up with often interesting and useful suggestions for people to better understand the disease. My experience in this is mostly in personality disorders and in offering what you'd call a not a destigmatized report. Because personality disorders are notoriously difficult to give feedback on. It's like you can't call someone a narcissist, but you can give them a really, once you learn enough about them, you can give them a very well structured feedback on like how they are and their impact on the people around them in a way that's very acceptable to them. That's incredibly hard for humans to do, but we found that AI can do that to a good degree. Um, so what that means is you're completely right. So we have to think about like the three things are still true. So you still need the data to make the individual patient predictions. You need to be verifiable, meaning there needs to be humans before them, in a sense, who have broadly been in that same space, which is why we even have the data. And again, we're all talking about digital things. I think when it comes to unique biology, there's a lot of interesting effort on continuous monitoring and different tools to different measurement tools, which is why I think measurement tools will continue to explode uh, for personalized healthcare to occur, like on this slide, like because you need more measurement. Can you mention what you said? You encourage everyone else here to look at from Stanford. I can't quite remember what it was. The two things I encourage you guys to do though is there's something called Arise AI. It's one of Stanford's almost I think it's almost like a newsletter where they go through all of the clinical advancements in AI and offer their thoughts on it and give good news on it. So it's important for us to all stay up to date. So Arise-AI, I think if you just search up Arise AI Stanford, it will come up. Um, the other thing is probably this talk by Jason Wei at the Stanford AI Club, which I think is still important to. Um, it's a very good talk, and there's a lot of cutting edge online resources from their YouTube channel and everything, which I encourage you all to look at. Yeah, we believe that things that we can do better, we can't measure those things. Yeah, yeah. Well, it's entirely possible we can't, right? If we have this thing that is the best mimicker of the top 1% or top 0.1%, then the general average like human can't outperform. And maybe that's okay. Maybe that's like the next step in human progress. Because all it means is you have excellence everywhere, which is good for patients, right? Yeah, because we pivot as we go. Are there any models currently learning from African LLMs? Hmm. I'm not sure. Is there an AGI for medicine, and what's its use case for us as clinicians? You can't ask me difficult questions like that, man. I don't know. I think current models are still what we call spiky, meaning they are exceedingly exceptional at certain domains and far less at others. For instance, I feel like the reason it's able to do competitive, like competition level math is because of the three factors we talked about. But things like clinical reasoning in a very complex patient where there's so many interacting factors, it's possible that it doesn't have as much of a precedent in it. Although personally, I've seen it performs quite well. Um, I think the use case of us clinicians is to continue to translate it, in my opinion, because there's a lot of physical tasks, there's a lot of non-digital tasks that it can't do, and I strongly feel that um, if like we need to embrace it as a technology because it's obviously very good. It's obviously going to be good for patients. And my overall goal is to continue to translate it just because it's going to help my patients better than probably I can in my lifetime. So there's no reason why I shouldn't continue to translate it. But you guys will realize that AI will as you continue to do projects here is that it itself is such an incredible tool that will solve so many things, but it's a common adage that AI folk will largely overestimate its impact and underestimate its like how difficult it is to translate. Just because you need to teach everyone, everyone needs to be on board because otherwise you're going to leave so many people behind. Everyone and you need all the infrastructure in place for it to be translated everywhere. Um, and everyone knows, yeah, like there's so much work to do from a translation perspective. Collaborate with the Kyle Labs. Yes. So feel free to email us. You can find us anywhere here. That's just my email, but you can also email Kwa, the head of the lab, at kwa.cao, CAO, at monash.edu. And then you can chat to us about anything. I think we'll be employing shortly. Not right now. I'm not sure if we have vacancies right now, but yeah. An African focused AI research topic. Um, I think I'm probably someone since I don't live in Africa, I don't think I'm the best person to answer that question. I think um another thing is don't disregard your specific knowledge, meaning the knowledge that you have that no one else has, because that's the way that interesting and important problems are solved. For instance, um, there's a project we're doing with a very niche, small rural town where we're helping the nurse see uh, like basically helping with clinical decision support for this nurse who works there, who's the only clinical staff who works there. That's a very in like that's a very niche problem. But the impact it can have is disproportionately great and like to the people there. And it's only a problem that we know of because one of our staff members comes from that town, right? So it means that you know the problem better than anyone because you're the one who's lived it and seen it. So I think that's one of the best ways to approach problem solving.
So I think that's all for the questions. Wow. Thank you so much, Dr. Deepak, for this session. Okay, there's an extra question. Um,
How does
Doctor,
automation
I
come
don't know
into
if you can see
medicine?
the question, yeah.
Oh yeah, yeah. Hmm. Automation comes into medicine insofar as we are happy to automate things. Uh, we are probably happy to automate referrals to other clinicians, like because that's something that's just frustrating for us to do. We're happy to automate documentation. Uh, but I think at some point patients won't be like it also matters what patients want. So if patients have a impression that AI can do like they can talk to their AI to help them with the clinical things, then they're going to automate that without us like really saying anything. It's sort of how patients Google things to find out more about what they have. We don't really have a say in that. And it's entirely, they should do that if they want to, and provided it's safe, and we should advise them for what's safe. But yeah, automation is mostly a social factor uh, for what we allow. Because at this point, with agents, like if you think about it, so many like clinical things are automatable now. It's hard to really draw that line for what's automatable and not automatable. It's a matter of what we allow.
Okay. So thank you so much, Dr. Deepak. Let's go ahead to say thank you on the comment section, or you can just react with an emoji. This was an impactful session. Like, I was like, how many questions do we have here? Close to like 15 or thereabout. Thank you so much, Dr.
All right,
Deepak.
thanks
This
everyone.
was an amazing one. So, I think at this point we have to ask, they're still coming up with questions. I don't know if we can take all those questions. Um, I don't know if you can see the last question. I don't know.
Oh, the outbreak one?
There was one, how early can AI actually detect, yeah, the outbreak, the one of outbreak?
Yeah. I mean, it's an interesting question. I think we have to think about so if you guys don't know, like a lot of where progress is made in AI for predictive AI is where money can be made. So a lot of it is about predicting like house pricing or predicting the stock market. And if they can predict the stock market, which is just such a complex and adaptive system, I feel like if the right data points are available and the right environment is in place, you can probably predict an outbreak early. It's unclear. I'm not a public health physician, so I don't know like specifics on what you need or the environment or the data required, but I feel like that's definitely a solvable problem to some degree. I think the far more difficult thing and the like if you guys remember the sepsis prediction, right? The far more difficult thing is putting all of that in place in a way that integrates with everyone's workflow, in a way that's acceptable to everyone and understandable by everyone. Uh, yeah, like and also it's early prediction for outbreak for who exactly is another thing. So is it for public health physicians or is it for um it's I can sort of bet with you that you can probably have oil rig companies with who have like workers living onshore who companies have a strong financial incentive to not get sick who which means you have enough money to you have like buyer as well like that as in like well, what I mean is that um even if it can detect an outbreak early there's the whole like line of the problem population outcome like payer that needs to be solved before any like clinical thing is translated into practice. And that's about biodesign. Oh yeah, sorry. Wait, the thing that I wanted you guys to read up on is like the Stanford Biodesign program. And there's a good book on biodesign as well. That's if you're interested in translation. Like that's something that I've read like I've spent a lot of time studying just because it's actually very like useful. It talks about regulation, commercialization strategies, blah blah blah. But I think there's so much that goes behind why some problems are solved and some problems are not solved. I'll just leave with like another thing. So, for instance, I was really interested in trachoma, which is the like the eye disease in indigenous populations in Australia, and because that's they have a disproportionate amount of trachoma, and then I realized that they had a I can't remember what it was. It was like the percentage was quite high, and they were aiming for like 3% or 5% prevalence, and it was called the Eliminate Trachoma sort of project. But then the real target was 3 or 5%. Now, I want you guys to tell me or guess what the um, what the rate of trachoma is now. So this project ran until they got it down to that level of like 3 or 5%. Let's say 5%. What do you guys think the rate of trachoma is now in this population that they were trying to affect? The the name of the initiative was to eliminate trachoma, and the goal was 5% of trachoma, and they gave a lot of funding to do that. 1510. Okay, wait, actually, I don't think we have like good data that's like up to date, but it's around 5%. So what I'm basically saying is that even if you have a project to eliminate trachoma, it's the bottleneck is really in the money behind it. And once you finish that project or hit that level, then the problem is considered solved and the project ends. And then you end up with like you don't end up eliminating trachoma, you end up with 5% trachoma. So it's just a matter of like what like people want and what people think is acceptable, especially from a health system perspective. Anyway, that's a very much a tangent. But yeah, I need to hop off in a bit. So
Okay.
if people don't have any more
Okay.
questions,
So thank you so
apologize.
much, Dr. Deepak. I think someone was requesting for the name of the book or the not book, the Stanford course you were
Oh
talking
yeah,
about.
yeah, yeah. It was a book. Let me see if I can find it. I think it's probably this book. I think I read an earlier version of it, like an older one, because I was borrowing from one of my supervisors. But again,
Okay.
this is very it's a lot more about like specifics of translation though for
So
um
thank you so
yeah,
much, Dr. Deepak, for this.
no problem. Thanks, Ron. Thanks for having me. It's been fun.
Okay.
All right. I think I'm not sure if my internet is good, but I'll head off. Thanks, Ron. Bye.
I'm I'm trying to check the link. Thank you so much, Dr. Deepak. This was amazing. Like having so many questions come even after the webinar, and still for some reason So thank you once more, everyone. So every other thing we communicated on the WhatsApp community. Like I said, tomorrow is going to be massive. So let's come prepared. Thank you so much, guys.